Okay, so today we continue on with another limit example. We've got here the limit as x approaches pi over 2 of tan x. And as you can see over here to the right, we have our graph on the board. I was a little careful with this one with the ruler and everything because we're going to rely heavily on the graph. So if you actually graph tan x in like Desmos, you'd see it's not just two curves, it's like an infinite number of curves. So this curve basically just repeats. And then in red here, you'll notice we have these vertical asymptotes. These are the problem points. This is where the graph's going off to either positive infinity or negative infinity. And it happens, one of these is right here. This point here, this is going to be at x equal pi over 2. And that's what we're looking for right here. They're asking us to find the limit as x approaches pi over 2. You notice in some previous examples we did, we're able to just plug in the x value, right? If the value we're looking for is not a problem, like for example, if just pretend the question was they wanted the limit as x approaches 0 of tan x, well, we really don't have to do much. We can just plug in the 0 of tan x and we can get 0. We can look at the graph at 0, we can clearly see it's 0, and there's nothing complicated going on there, right? What we would do to be more precise, checking left and right hand side, is we would like check this at 0 plus, and we also should check this at 0 minus. But the thing is, like I said, there's nothing really going on. It's going to be 0 at both points. Both points agree, and so the limit of that's just 0. But for the problem we actually have, we see here at pi over 2, it's kind of a problem point. But just looking at the graph at pi over 2, we can see things are a little more complicated. We're going to like negative infinity here, positive infinity. So let's do this carefully when we look at the limit of the right-hand side and the left-hand side. So what I'm going to do is we're just going to evaluate this, look at the limit as x approaches pi over 2 plus, and we're also going to look at the left side, of course. And so looking at x as approaches pi over 2 plus from the right side, that's going to be somewhere in this area, but you can clearly see this is going off to negative infinity here. And it makes sense if you think about tan x, tan being sine x over cosine x. Well, at pi over 2, cosine 0, so we have like a divide by 0 situation if you just think of this as sine x over cosine x. But then now let's evaluate this at pi over 2 minus, or on the left side. So we'd be kind of going up here really close to our asymptote, really close to pi over 2. I know my graph's not that great, but if we did that, you would see that on the left-hand side, this is actually going to infinity. And so the trouble for our limit is when x approaches pi over 2, we want just one value. And what is it? Is it going to infinity or is it going to minus infinity? Well, we don't know. These aren't the same. So when we have the situation where the limit on the left side is not equal to the limit on the right side, we just said this limit does not exist. So one thing I thought was interesting about this that I want to go over before we finish, if we had some integral now, and you may not be familiar with integrals, but don't worry about it too much because the point is really about limits. So let's not worry too much about what this integral is, but let's just say there's a tan x in there somewhere. And then let's say with this integral, I want to make a u substitution. So I'm going to make my u substitution equal to tan x. So when we do that, we always update our bounds. So we plug pi over 2 into tan x. And when we do this, we always get infinity. We plug 0 and we get 0. And the point I want to make is when we do this, we often say, well, tan at pi over 2 is infinity. But if we look at this, we found that's not really true. First of all, like the limit of pi over 2 doesn't exist. There's not really a value at pi over 2 because we just have a vertical asymptote there. It really could be minus infinity or infinity. So why did we change this to infinity? Why didn't we change it to minus infinity? But the thing is with these bounds, for an integral, what's really happening is this is really pi over 2 minus. We're really looking at it on this left side, or if you think of the unit circle, 0 to pi over 2, with this being 0 and this being pi over 2, we're evaluating in this whole region, but we're not really worried about the endpoints. We're worried right up to pi over 2, so we're really worried about pi over 2 minus. Because if we really were looking at pi over 2, we'd have a big problem, right? But if we look at it at pi over 2 minus. Okay, so interesting limit problem here. We'll stop it there. Thanks everyone for watching. Have a great day.